evening, everyone. I'm Jeremy. What is interesting is that I have been a app developer for over 10 years. But as far when it comes to app development, I don't find it changes too much. Let's don't talk about, right now we do have a much easier, higher level API. I can call one thing and the SDK will do a lot of things. But in terms of developing an app, you start with your UI and you start attaching some event handler for when you click this button what to do, and then call the library, and then render the result on the screen. The process has, the way you do this haven't been changed. It's only recently that we started to think that what if we can start incorporating microservices into the app. By this, we are not just talking about have an app talking to a cloud microservices. What we are talking about is the app actually is made out of each individual microservices that talk to each other, and then the result was a very thin layer to render the result on the UI. So this is basically what I'm gonna be talking about this evening. I'm gonna be taking you guys through the journey that we developed our app using an API first edge microservice approach. Specifically, we're gonna be using mimik access as an example, how we go about this one. For those of you who don't know what mimik access is, mimik access is pretty much one of the apps that we developed to test out this idea, and as it's one of the crucial apps that we use to also test out our mimik EdgesDK to make sure it was working. Mimik access itself is pretty much Google Drive meets Facebook at the edge. So basically, you can actually share medias with your friends. You can form like a little social group among your friends and share each other's music, see each other's what you have put down on your device, and you can actually see each other. And we do this one. Most of the communication actually is between microservice talking to the other microservice on your devices. Basically, peer-to-peer microservice talking to each other. Yeah. So before I start walking through you guys with the journey, I would like to share with you guys a couple of app development challenges. The networking. It's always today's one of the biggest challenges we'll develop app today. It's just, you need to make sure your app can work under different networking conditions, whether the network could be go off or down this. We require some kind of feedback, or the app can still work, don't crash. We also want the app to support multiple platforms, right? So right now for the mobile platforms and some of the consumer platform, we have iOS, Android, Windows, and Mac OS. And also there's Linux. And then for the geeky, more like hands-on community, you might want to develop your own IoT application. You want to make sure the app also works on the Raspbian, right? And the QNX is one of those operating systems that right now it's your smart car. Actually, a lot of them is using the QNX platform, and it might be they might in the future they might allow you to actually put apps directly on your car, for example. The third challenges that developing app that we're facing right now is actually in testing and debugging. So right now, let me go into a little bit more detail what kind of networking challenges we're talking about here. By the way, it's not just limited to this. There are a couple more. There are many other. Tonight I'm just listing out a couple more. I would say something that when you develop an app, you have to consider. Otherwise, for the UX, you're gonna get affected, right? So right now the networking problem. So what are the networking problems? Networking failures. So pretty much is what if there's no connection, or you walk to say under the elevator and suddenly just don't have any connection. And if you was working with some kind of a real-time communication app, when you walk out of the elevator, you kind of want the app to recover itself. You don't want the app just go crash or say, I don't know what's going on, right? And then we also need to deal with latency. And actually, I find this is where most of the bug that came from with today's app. Why dealing with latency is so difficult right now is because it's very difficult to simulate a slow or unstable network. To simulate a network failure is very easy. You can just turn off your Wi-Fi and start just go through your app, see what's working, what's not working. But when you want to simulate slow network or connection is on and not, is kind of difficult. You might need a couple more external tools to help you do that, and some of the app we just don't have enough time to actually deal with this one. So a lot of time you see this problem actually, you report this by the actual end user. And then we have the scalability and cascading failure. Let me give you a very simple a story here. So imagine there was a change to your app on the UI. So you push out a app updates. And the new UI, apparently to deal with the old data, is some bug. We haven't been able to catch it during the development piece because this very old data. Some people didn't probably use this app for a couple months, right? So the UI doesn't know how to render this data. And then when the user actually update the app, start using the app, they see, oh, how come my screen is not showing anything? But actually it is showing something. It's just the UI doesn't know how to render this old data, so it doesn't show anything. So the user, what it will do first is start refreshing the screen. Just keep refreshing and blah, blah, blah. And then what does is that usually the app will start making API calls to the backend. And imagine this problem is not just one user. It's like maybe 5,000 of your all users. And imagine 5,000 of them start refreshing, and this is API request sending to the server, right? And then now your server for scalability issues start doing scale up, scale down, and then usually what will do is there will be some limit on the API calls, because it's, oh my God, it's too many API calls coming. What's going on? So start limiting this one, and then now it will be causing a cascading effect because your app might be the backend application might be there might be couple of your apps using the same backend application calling this API. Now, because this particular app is causing this API limit, now it actually affect your other apps. Like suddenly just doesn't work, right? So
especially if it was caused by latency.
Yes, yeah. All this one. So all of them actually intertwine with each other. And as an app developer, you are not just trying to develop an app. You also need to be like a network super engineer to actually think about this, right? It's very challenging. And also, we also have the problem with dealing with security. By this, I'm talking about what if a token expires, you need to renew the token and stuff like that, right? Like because we do not want the user to log in again. We want the app to actually renew the token using something called the refresh token. Because right now in this days, we have access token and refresh token. Access token usually is a shorter period of time. And then we use the refresh token to actually get a newer token. And by this, when the app comes to the backend to say, give me a new token, the backend has ability to actually think, if I can give you a new token, so it can actually put some logic to actually do that. So without actually forcing the user to log out and log in again. But today's app needs to deal with this gracefully. Otherwise, you're gonna have some trouble here. And then we have the multi-platform support challenges. By this, I'm actually talking about basically we need to work on multiple UI. And then why do we want to work on multiple UI? Especially for iOS and Android, because these two platforms has very different design languages. And yes, you could have come up with some UI can be shared, among these two platforms, but sometimes just to represent some of the UI, the UX experience, you want to have the UI that's more aligned with what the platform UX experience is. For example, the back button, it's there on Android, and usually you don't need to show back button on your UI because people know how to hit the back. But in iOS, there's no back button. Usually you see a back button on the UI. So anyway, so we have this type of thing. And then if you want to do this platform-specific UX, what you usually need to end up with, you need to tie it to a platform-specific SDK and programming language in order to best use of this access to this UX. And another big one is that right now the app is all about cloud communication, networking codes. And when you to deal with all this networking codes, you want to make sure you know how to do asynchronous programming. And then again, on different OSs, they give you different tools to deal with asynchronous programming. On iOS, you will be recommended to use the Grand Central Dispatch. That's part of the OS function provided to you. They encourage you to actually use it, right? On Android, you have a sync task. And this tool, the way you approach it is a little bit different. So sometimes, even though the two functions, it might be, because you use the Grand Central Dispatch is much easier to implement than using a sync task. So even to achieve the same thing on two platforms, there's still some challenges implementing them. And then when it comes to testing and debugging, in the app developer, you also have a very interesting one. So the moment you want to do automated testing, usually with the app developer, what we are using is we will be using some tool to simulate button click. So you can actually have a UI and simulating the button click on your actual UI to actually go through different part of the function instead of having another person to do manual testing, right? So that's part of the test automation. And to do that properly is actually pretty difficult because say you actually update your UI, instead of button here, button was somewhere else, and then based on what kind of automation test you work, maybe you will send in the wrong, when you click in the places where there's no button, therefore you need to spend the time to optimize your automation test, right? And another thing is sometimes I just want to make sure the business logic of my app actually works fine. And then if you do not decompose your app to the way we have different units, it's very difficult to do this one. So yeah. And then when it comes to the debugging, another challenge is a lot of the bug is actually you don't find it when you have a device beside you. It's actually out in the field and somebody just left on the board, it doesn't work, that doesn't work, and then it's very difficult to figure out why. And a lot of the time, the only way to actually figure out why is by looking at the logs, right? And then when you want to look at the logs, you need to make sure how do you log, or what kind of device they have, because a lot of time it's very crucial that the person may have one of the older devices and you just don't have the time to actually test that one. Or the devices that has an older OS, it doesn't, so basically looking at the logs. And then also, you would like to reproduce the bug at the code level, so you can actually add it to your regression automated test to actually repeat this test to actually make sure the problem is actually fixed, instead of, download the next one and hopefully nobody complain, right? So how do we address these challenges? and this is where today's topic is. We actually find a lot of these challenges actually can be easily solved if we actually take the microservice approach into the app. And then one of the goal we were saying that it has the solution, if it's simple, meaning that it doesn't require to change too much of the app, or you need to redesign your app. It's very easy to add and flexible. You can adapt to any type of app, not just the specific apps. And redeployability. This one we will go into a little bit because with the way the microservices is, you can actually redeploy the microservices when you need it. You don't, if you don't need it, you actually don't need to deploy these microservices. And this is very interesting. I will go into a little bit about this one. And the scalability. So basically, the way you introduce the solution, it will deal with 5,000 user app to 1 million user app. It shouldn't change your approach that much. It should be just, yeah. So actually, what we found out is that by incorporating this microservice architecture, we actually don't need to change it too much. Because all we do is we actually tweak the MVC architecture just a little bit. So, but instead of using the regular like view controller model, we actually have a different semantics for that, just to differentiate what the tweaks are. So we have the UI layer. Basically, it is the view. It's basically the look and feel of the UI that you render data on the screen. And we have the orchestration. This is basically the controller of your MVC model. Listen for the user input, etc. And the most important thing is, right now, this is very important, is making REST API calls, because we want the orchestration to actually make the API call to your microservices. And then the microservices actually is your model right now. And then this, what it does is actually the model describe your business logic. How do you save your data? How do you protect your data? How do you manipulate the data? And also some business logic of how do you communicate to other microservices to actually accomplish this business goal. And then most important, it implement the actual RESTful API. And by taking this approach, actually when we start developing app right now in Mimik right now, we actually talk about what API the app needs first. This is basically the conversation these days. When we have a new app we need to develop, we start talking about what APIs. So this is what the API first is. And a lot of the time, by discussing what API we need, we actually already can actually figure out, oh, actually we have a lot of microservices that we developed in the past can already reuse. So that's why I'm actually, instead of keep redeploying a lot of this business logic, we actually can reuse it very, very quickly. So here is just a general app flow of what you will be seeing if you're taking this approach. So you have a UI that's pushing the user input to the orchestration processor and return it, and the orchestration based on that will make the RESTful API call to your microservices, local microservices, and then return that. Then you render the API response on the UI. That is basically the flow here. So right now I'm gonna be using the Mimik Access as a example how we actually do this. So as you know, we have the UI. With Mimik Access, actually it's quite interesting. So we have a UI for iOS and a UI for Android, and a UI for Mac OS, Windows, and Ubuntu. Just because the desktop experience don't change it that much. We don't decide that we need to have a different UI. But for iOS and Android, definitely is a completely different UI because because the way people deal with iOS and Android are quite different. So we basically have 3 code bases for the UI. And when it comes to the orchestration all it does is just simple things like controlling native media player, whether one player stop, and then majority of what the app does is actually making RESTful API calls. And now we go to the microservices, and if you look at we're actually utilizing 3 microservices in Mimic Access. We have the mSuperDrive. Basically what it does is this microservice, all it handles is discovery. Mimic Access have the notion of forming social clusters. So we have one cluster, social cluster called send local network. So if you are within the send local, you can actually access each other's device if you put it into your shareable. Basically, you pick this item to be shareable to everyone. And we have the same account, and this one is basically all your devices have access to. So the moment you log in with your account, any of your devices that you log in with this account, you can actually access this that device's media without specific go to each other, say I don't want this, I want this one. And then we also have the friends. So you can also say because you are my friends, so you can actually access to this set of medias. And then we have one microservice to handle the discovery of the social clusters. And then we have one microservice to deal with media services, meaning that you can actually put your shared media hosted on your phone. So instead of go to the cloud, you actually go to your devices to actually retrieve those medias. So that's actually handled by the M Drive. It works very similarly to the Google Drive. And we also have the virtual me cataloging service. This is for the account cluster. Basically, we're generating a catalog of medias of your phone. And therefore, when you want to access your other phones, you're actually browsing the catalog. Yeah. And then we have this media content binning. This is more for the ad hoc one. Sometimes you have a very specific data that you just want to quickly share it to someone, like friends or a stranger. But you not necessarily want to share it. You just want to just for this instance. So we have something called mbin microservice. Just pretty much this one pretty much works as sending like a messages, like almost like a rich media messages. But this is from the API point of view, it's doing that one. Yeah. So here we have, so let me go into a little bit deeper about what MB API. So this MBin API, pretty much the resources or the model, think about is pretty much a messages, and it can store, can retrieve. And like what Michelle described earlier, we start implementing the microservice by specifying the API. All our API is public available on Swagger Hub. Actually, let me just show you guys what this API looks like. Yeah, so see, we even have keep different versions of our API, so you also know that. Like for here, if you want to see a list of messages that has been available, you just call the get play queue API, and that's basically what the data returns is. You can see the name of the item that was binned to you, and the MIME type is a JPEG, and here are the URL to actually reach this particular URL. You see all this encrypted because inside this microservice we were generating spatial tokens, like what Michelle mentioned. Every microservice endpoint is protected by the token. We are not. It's microservice. All the microservice endpoint are protected by this one. And in mbin, based on the criteria the API chooses, the owner can generate different access token, and that was being shared to to the person that you want to ping with. So basically what we do is, if you want to share a photo to your friend, basically what the app does is actually calling the mbin that's on this phone. And this mbin has the mechanism. It knows that, oh, I need to talk to your friend. So it will actually, this microservice will talk to another microservices, the mbin microservice that's on your phone, and then push this message over there. Before it pushes, it will generate a token and push there. So when the other one, they start browsing this one, it will be able to actually come back and then use this token, therefore you can have access to this particular media file. And in this one, you can also say expired time, so like maybe 2 hours, etc. Right? So this is just one of the example here. Yeah, and then we also have, for example, you can you can get a specific item instead of a list of items if you know what that is, and you can remove it. This particular one is just to handle this specific endpoint, so that you can actually stream the file. So, and then this API is for the app to actually generate a special token. As you see, all the function of the app is actually described in this APIs. Yeah. I just go into the actual code to show you one of the endpoint, how we implement it. For example, this get play queue. See get play queue, and we actually have owner code, so all the APIs protected by some kind of token. And the owner code is when you deploy this mbin microservices on your phone, you can actually specify a owner code. Again, this is handled by the app itself. It will generate a special owner code, so only this particular app have permission to access this particular microservice that's on this phone. It's not just anybody who can access this one. And then those are just pretty typical code. It's going through the code, grab it like that one. Yeah. So now the next one is the super drive. As I mentioned, this is used for discovery. We also have device presence check. This one is very interesting. When we have forming the social cluster network, especially on the link local one, people can come and go. The change is very, very fast. So sometimes, okay, when you see the thing on your list, you can actually you have to use this specific API to check if the device is there. So we actually have this particular API. So instead of the app guy to actually figuring out how to check if the device is there, so there's actually an API for the app to actually call to actually make sure if the device is actually there at the time. Because the people might come to the network and then go right away. So on your UI, you might see, oh, there's a device, but when you click it, where is that devices? So we also have a specific API for that one. Yeah, as I mentioned, the M drive is just to deal with the media data that you would like to share. And here's the APIs. So here with the traditional cloud approaches, without Mimik EdgesDK, you have to run all the microservices at the cloud. So with the traditional way, you will have your mbin, M super drive on the cloud, and your app will talk to it. And when you want to bin something to the other devices, you will use something called a push notification to actually push you to the other devices. There is no direct communication between this. Everything has to go through the cloud to actually in order to reach device 2. So with our Mimik EdgesDK and this whole idea of edge microservices, so what you can do right now is instead of putting the 3 microservices in the cloud, you can actually put it directly in your app. So your app, when you're communicating, so for example, you want to bin one to that, it's actually 2 microservices are actually talking to each other, not go through the cloud. It's directly talking to each other. what we also mentioned that there are other typical cloud services that it just doesn't make too much sense to bring it to the edge. Again, we are not anti-cloud people. We actually coexist. We're actually enhancing the cloud. So you can see the application still calling the cloud for the user profile and the rest.
Excuse me. Are they connected?
Huh?
Always connected?
No, they are actually not always connected. That was why the device presence check. When you finish your device presence check, actually Mimik, we have some facility to let you know how to reach the other devices. So for example, if you are beside each other, we will actually just call the IP address. Because you are in the same link local, you can just directly communicate it. When it's over the network, we will actually use one of our backend feature to actually give you a specific proxy temporarily over the network. You can communicate through that one through a spatial tunnel. Yeah, we call the SEP or the BEP. Yeah. Yeah. So now let me just go into how with this architecture we actually addresses the network challenges. So the very first thing is all these network challenges can now be done in the edge microservices. In particular, the sidecar that's actually initiated for the microservices. So in the sidecar, we have code to actually handle automatic retries. Because a lot of network failure, all you need to recover is just retry again. You don't need to tell the app saying that something's wrong. It's a simple retry. It'll work. Because you might as well come out of the elevator, for example. You can just retry it again. So this can be automatically done. And in terms of security, we'll renew the token, etc. And then when it comes to the scalability, this is one of the biggest benefit of bring the microservices to the edge, because right now, your devices now becomes one of the cloud instance, right? So the more devices you have, the automatically you have more instance, because every app will deploy its own M drive and super drivers, etc. to actually deal with that. You don't need go to the cloud to actually do that one. And then the edge microservices can utilize something also called the circuit breaking technique. So if the API coming from the UI is too much, it can actually know when to stop it instead of having the actual network traffic go to the actual backend. So it can actually be stopped. So that can actually solve a lot of cascading failures. What the API first approach is that it allows you to start abstracting your business logic. So basically, all your business logic is actually API calls now. So if you implementing one microservices, and then that microservice can actually be utilized on different platforms. So basically, what happens is that the UI can use the actual native tools to actually render it, but the business logic is actually using the same code base, because the microservices is the same. You can actually deploy on different platforms. Like the microservice that we built for M drive is the same. Doesn't matter if you're on iOS or actually Android, it's the same one. And then calling that API code is actually kind of straightforward. So that's why we say the UI and the orchestration actually becomes simple and nimble, meaning that if you want to change it to another API call for the orchestration layer, it's simply calling another API. You don't need to start, okay, how do I do this, how do I do this? And all you need to do is deploying different microservices. Yeah. So this is how we address the multi-class platform support. That's why we can rapidly support many different platforms. And then also this also helps a lot in the testing, debugging one. So a lot of the apps, what you want to do is right now the test automation can simply be testing those API calls. So right now I want to make sure I can bin from bin from this device to that, all I need to do is test the API if I can do this to the other. If it works, it works. And it's just up to the UI to actually show the actual progress by binning to that. But in terms of the actual function, you just need to call the API. And this one can be tested easily through automated tests. Like this is, you don't need any fancy tool to simulate button click and etc. This is just simple coding API tool. And also, in order to reproduce a lot of bugs, actually it's actually pretty simple because a lot of bugs happen because the API wasn't implemented properly, or this API causes the app to misbehave. So you can actually start marking the API response to actually see how your system behaves. So for example, it's your binning part that actually causing the problem. You can easily mark the response of the binning, the response to that, and see how the other end of microservice will respond to this data. So you can actually fix your bug really, really quickly, especially for this cross-platform communication. It's just looking at API, you can actually solve majority of the bugs. Yeah. And the logging actually is simply just logging the API codes in your microservices. So your apps crash if you can get a list of your logs that the microservice receives. You can actually figure out what the app has been doing at the time and what data has been, if the data is broken, because you can also log what the input to the microservice is very easy. You don't need to go through your crazy spatial log, like log framework, because log framework is different on every single different framework, right? Yeah. So right now, demo time, let me just quickly show you what the mimik access is. So I will invite my friend Mass.
Hello everybody.
So this is actually the mimik access. So right now I want to use this mimik access to discover what is nodes or my social group that is actually within the same network. So I just click here. Yeah, see, right now the Wi-Fi is the link local one. So this is just simply calling the mSuperdrive API to show this list. And then your Samsung one, right? So I click it, and here I can basically browse whatever he's sharing.
Yeah, so
Yeah.
pretty much if I go,
Yeah.
so stay on the pictures,
Okay.
go to pictures, images.
Yeah.
So if I add these two pictures.
So what Mass is doing, he will add additional photo to this specific share spaces, so I can actually see it.
So if you refresh.
See, right now, this is actually, so this is actually the photo.
I just took that picture when I came up, so.
Yeah. Let me actually bin something to you.
Yep.
So this is actually playing the music actually from this phone. Yeah.
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 And it
Yeah.
works cross-network, so they don't have to be on the same Wi-Fi.
Yes. Yes. Yeah. So yeah. Okay. The app was never go to the cloud, stays on your device. So that's why you can see it's so fast. It's immediately. Yeah. Yeah, it's all it does is sending a messages to this phone saying that I want to share this one to you, and then I just need to click. Why don't you ping something to me?
I
Okay.
just did.
Okay.
So if you go to
Okay, right here. Yes. Yeah. Here. Yeah. So that's basically straight from Mass's
Samsung.
Samsung. Yes. Yeah. Oh yeah. Not on iPhone. Okay. Not on iPhone yet. Yeah.
It's because you connect to that connection.
Yeah, because I think this laptop was slowing it down. Yeah, because this, yeah. Okay, yeah. So this is.
No. No,
No.
it works cross-device, cross-operating system, cross-network, and cross-cloud. So it's literally removing all the time. At every location. So what Mimic does we have an end-to-end communication platform, right? The EdgesDK is one of the main components, and this EdgesDK enables devices to discover each other and form these ad hoc clusters based on network ID, which means we're all attached to the same Wi-Fi, based on proximity, which means we're all in a vicinity and we can be attached to different networks, and based on network. Based on account, which means that, for instance, my device, I'm here and I have a device in LA. So that's the three ways. By doing that, you're basically forming the fabric of cloud, and you allow these devices to discover, connect, and communicate within each cluster and across cluster from each other. And that's what we take care of. We ensure that when your application wants to reach a destination and go to another device, we deliver that either through direct mechanism or through instantiating an intermediary node. But we take care of that part. And then when you run this application, that for instance, as an example, Jeremy showed you, in terms of access, which is an application microservice. Now, by enabling these microservices on these devices to communicate with each other, you're pretty much creating the fourth cluster, which is the cluster of communications of this mesh service or service mesh, right? So now you have a full control in terms of where the most efficient place is for me to create this communication. And now you break your application to further app and microservice. That means that your application is much more nimble, and the perceived quality of experience for end user is much better. And when you develop this microservice, which by the way, they're all serverless microservice, which means it's not running in the background constantly. By doing that, you're very efficient on power consumption as well. So the microservice is not running until an API gateway gets called for the microservice and you're launching it. So pretty much is model of serverless microservice architecture.
So I could ask a group of sensors work on Wi-Fi and work on Bluetooth in different locations, and yet I can actually create an application that talks to all of that.
Absolutely, absolutely. And that gateway, you know what they call, what they're right now referring to, come here, Michelle, what they're now referring to as IoT, fog computing, where you have gateways that need to be attached to your sensor. Yeah. And now these gateways each have their own ecosystem of, you have Google IoT versus Amazon Green Glass versus this versus that. But they're really disjointed. There is no, if you want to talk from one provider to another provider, you can't do it. With Mimic, your device is literally your gateway. So your application can now see, your sensors can send information to a microservice application that basically running on your iPhone. So imagine the user comes and now these informations are received from your iOS to your Android to. So it's really breaking the barriers of being vendor locked in. Anything you guys want to add on this?
Yeah, I also want to add, because you mentioned those small sensor, I would say the very resource-constrained devices. So our Mimic EdgesDK actually is by itself is very small, 5 to 6 megabytes.
5 to 8 megabyte is
yeah.
the EdgesDK for Android, iOS, Windows, Mac, Linux, Raspbian, and it's also QNX compatible. And the memory consumption of the EdgesDK itself is about 100 kilobytes. So it's extremely efficient in that sense. And then you can do dynamic deployment of microservice. So an event occurs based on the event that you receive from the IoT sensor. And now this may require a macroservice to get instantiated on an edge device, on a gateway, or on your iOS, right? And that you can actually dynamically receive that and deploy it on the device. So you become like a event-driven macro service deployment, and that's what we meant by redeployability. Because when you download this macro service on this device, on this edge device, now this device itself is an image holder of that macro service to now gets deployed on another device. So you're creating a complete mesh of service communication that is now faster and cheaper. Again, Michelle, go ahead.
No,
Anything else?
no.
Yeah. Any other questions?
Does it run on background on iOS?
So,
Background process?
okay, so on iOS is a little bit interesting. So the iOS is, yes, is running on the background. However, Apple, the iOS operating system, the moment you actually switch to another app, it will be terminated.
Yeah.
But when you come back, we will restart the EdgesDK. And the stopping Edges is quite fast. Couple seconds, that's it. Yeah.
Yeah, and so the EdgesDK runs as a service, and one instance of this EdgesDK is enough for, so you, on any device, on any operating system, you only have one EdgesDK that it runs. And this EdgesDK is serving these different macro services and applications. So to some degree, you could kind of look at it as EdgesDK is a multi-tenant itself. And then when an application gets developed, it gets the key OpenID through an OpenID Connect from our OpenID Connect server, and also the macro service has its own key as well. So we have you have the notion of application ID, so that therefore you're multi-tenant. So on every operating system, you have one instance of EdgesDK, but on iOS, every app contains its own EdgesDK. But because we have the mechanism of app ID and token management and all those, we still maintain the uniqueness of that device ID. So we still know that yes, this application has its EdgesDK, but the device is still a single device.
From a security perspective, so privacy and authentication and authorization. So
Yes.
I noticed that you and your friend, really shared information. But what if I don't want to participate?
That's an application logic.
That's not. So
That's
Yes.
completely
Yeah.
an application logic. But we have 3 levels of security in our system. Go ahead.
So on security, we do 3 levels. First, we encrypt the connection using keys. Then after that, every
The
API,
keys are at each node.
key on each node, and the encryption. The problem is because we cannot use HTTPS, because it's on the local network, you deal with IP address and not DNS, and HTTPS only works against DNS. So that's one. The second level is we encrypt, we have keys on the API, so which means that you have to have the keys in order to invoke the API, and the application can decide that, but basically you have keys. And third, because of the fact that behind the scene, and we could explain at length the fact that we have this notion of supernode, which means that you have nodes which are more important than others and will collect some information. The problem is if you start to collect information on behalf of another node, you should not see what the payload is about. And so that's the third level of security. When the payload addresses a user, it's encrypted. So even if there is an intermediary node which basically captures the data, the node will be able to capture the data but will not be able to understand what's inside the data. And that's a 3 level of security. But on the access, the security is based at the application level. I authorize you to see me, which means that when I do this, then of course you see me, but you cannot see me before that.
Yeah.
Let me just add one more thing. The microservice that you develop those encryption we actually leave to the microservice developer to decide what kind of, if they want to encrypt it or not. Some of the app they may choose not to do it, but if they do choose it, we do provide some libraries that they can hook up to easily encrypt it if you want to do it in the microservice.
And also
Yeah.
every microservice runs its own container, so there's also the separation in that sense. And in addition to what they mentioned as we applying AES 128-bit encryption on any data that we also receive, so it's completely secure in that sense. And for the tunneling, because in order to create this communication, sometimes you have to tunnel. And for tunneling, we also use secure WebSocket. Please, go ahead.
I have a question for Michelle. It's regarding microservice architecture.
Yeah.
It's a fairly generic question. You're saying that each microservice has its own database, correct?
Yeah.
And if we're talking about persistence, if a microservice calls on a secondary microservice,
Yeah.
and the secondary microservice goes down, what kind of behavior do you recommend for the initial microservice? If it's not able to get that data.
Oh, okay. So, well, first you try to avoid that by saying that you create you create a cluster of microservice, which means that instead of just one instance, you have 2, 3, 4.
Say it's catastrophic.
Oh, yeah.
Secondary
So
no
if
longer-
it's catastrophic, you have then that was a sidecar pattern arrive, which means that at that point you basically go in recovery mode, and which means that it's not the fact that you as a microservice you fail, but more the fact that the connection fail. You may then have a logic to decide what to do, wait or retry later or things like that, in order to hope that at some point you will be able to fulfill the request. And if all of this fail, because it's like, then you have to return an error.
So
Because you cannot fulfill the request then. You as a microservice can do whatever you can, but if you depend on another microservice which is down and you waited for a long time, the cluster was completely down, you retry many times and so forth, and you still do. Sorry?
When you cache a response.
Well, the problem of caching is, yes, you can cache. The problem is you have to make sure that the cache is not stale. So which means that if the cache is not stale, yeah, well, you can hope that the cache information is still valid information. But if the cache is stale, then you're really in trouble. So it's like the cache is stale, you cannot reach the service. Generally, you have way other problem if you reach this situation, which means that maybe yourself won't work anyway.
Perfect, thank you.
Any other questions? So thank you everyone for joining us. This has been great. Thanks to my team, Michelle, Jeremy. Thanks to every Mimic team and employee. Please enjoy pizza and beer. Give us your feedback. We're still here. You can ask us questions. As I said, we're hiring. So careers@mimic.com if you guys are interested in any job opportunity. And we look forward to seeing you guys in future events. That we're going to be discussing business, technology enabled for business, so business challenges across different industry sector, and how you do application development, how you do microservice development. We're going to have all these conversations. And again, if you have any recommendations for topics that you like us to cover or you like to cover and present to the community, we're happy to host you and we're happy to enable you. Thank you, everyone. Enjoy.